Okay, tangents to circles. We have a whole page full of vocab. Before I show you the vocab, nod your heads yes or no. Do you have to write everything down that's on the board? Absolutely not. If you can handle this, take a picture, go for it. For example, look at your notebooks. What's the very first word? Circle. Do you really need to write down a definition? Okay, draw yourself a picture. So circle, what you need to remember is that the center of your circle, so maybe draw a little center of your circle. Center of the circle is equal distance from every edge of the circle. Hopefully that makes sense to you. If this will work, because what you'll see later on in your notes is an abbreviation for circle. It's this. So if you're talking about a circle, they'll do this. Q. So that just means circle Q. What do you think the Q is standing for in the circle? The Q is the center of the circle. So it might be like circle P if P is in the center. Circle A if A is in the center. Okay, radius. Same as before. Do you really need to write down that definition? Draw yourself a picture. What is the radius? Where does the radius have to start? Center. And it goes to the edge, right? So there's our radius. Radius is how much of the diameter? Half. So if you want to write that into, radius is half of D. Okay, congruent circles, I have a picture of them up here. Which ones do you think are the congruent circles? The green ones. What do we know about the word congruent? Everything has to be the same. So literally that's what congruent circles are. They have the same radius, so they'll be the same circle. Diameter has to go through what point in the circle? Has to go through the center. So just remind yourself about that. Goes through the center. Edge to edge. There's another vocab word we'll learn later. The diameter meets the requirement. Thumbs up. 1, 2, 3, 4. How do you feel about these 4 vocab? Wait, okay, these 4? Review, right? We've run this stuff. Okay, next part then. These three get confused. So if you want to write down the word parts, that's okay. So first part, chord. Major thing you need to remember about a chord is that it is a segment. A segment whose points are on the circle. So if you want to abbreviate that in your notes, I'm fine with that. And then definitely draw a picture. Let's get both down. Okay, so a chord, segment whose endpoints are, where are they on the circle? They're on the circle. Okay, so let me choose a color that'll work. I'm going to deal with this blue one. So from here to there, that'd be a chord. Stops on the circle, goes through the circle. Okay, question for you. Would a diameter be a chord? Stops on the circle, right? Goes through. Question, Ellie.
Does every chord have to pass through the middle?
No. It just has to go end to end. It has to stop on the circle. It's a great question. Okay, secant. Here's the trick for, I always get chord and secant confused. So you think of this. Secant has to be a what? It's a line that intersects in 2 points. So I have to think, all right, chord inside the circle. Secant can pass up the circle. So for example, this would be a secant. It's crossing at 2 points, but it's passing up the circle. Okay, tangent, heads up, I'm not very good at drawing these. I'm good at trying to draw them, I'm just not super accurate. So this one is another line, but it only intersects how many points? Just 1 point. I always start with the point and then I shoot for it. So maybe, for example, it's going to hit right here. That would be a tangent. It only crosses at 1 point on the circle. These are huge, huge concepts in this entire chapter. Chord, secant, tangent. Okay, Thumbs up with these three. How do you feel about the differences between these three? Looking at visually, feeling okay? Okay. They'll get reviewed. Next part. Tangent circles. Okay, so it's coplanar circles that intersect in one point. Maybe write that down. This is the key. Got one point of intersection. So if I move these circles on the board around, like for example, if I move that right there, oh, a little closer. What do you think? Do you think that gray one and red one are tangent circles? Yeah. If you hit it right, it'll be perfect. So they're crossing. They've got a common tangent right there. Oh man. Come right there. Common tangent. So that's our third vocab on this page. A line or segment that is tangent in two coplanar circles. So this one is focusing on the circles, tangent circles. Common tangent is focusing on the actual tangent. Concentric circles. This would be a concentric circle. If you had this circle and then there's another circle inside of it. So you've got to have your center point. So there could be another circle right there. That's a terrible circle. There could be another circle right there. They all share the center. So those are concentric circles. You've probably seen them a lot. So concentric have to have the same center, common center. Ugh, that's a terrible, terrible example. Okay, how do you feel about these three? Feeling okay about these three ones? Tangent, concentric, common tangent? Yeah? Alright, last four vocab. Interior. Guys, what does interior mean?
Inside.
So it's everything inside the circle. So however you want to write that. What does exterior mean?
Outside.
So everything outside of the circle. So just remind yourself, interior, inside, exterior, outside. Okay, point of tangency. That's focusing on the point. So, for example, let me move some of these circles around. I'm going to teach you two more vocab words, but it's off of two of those up there. Let's move these big guys. Okay, so we have these two circles. Question. Actually, copy them on at the bottom of this page first. Just sketch two circles. Good luck. While you're sketching, how many common tangents do you think that little green one had? No common tangents? Alright, if we draw them in, how many do you think they have? Two? Common tangents? How many common tangents could you draw? Heard three. Infinity. Now you're four. Can you at least see two?
Top and bottom, right?
Top and bottom. Okay, so right here. So we've got a common tangent. Sketch them. Oh, get ready to laugh. I don't know why I'm so bad. Hey, that might be the best ever. So there's one common tangent. So what this is talking about, the point of tangency, is the actual point, focusing on the point. Okay, well, like Moo said, if we've got a top one, there's probably a bottom one. So there's another one. Okay, but these have a name. See how they're on the outside of the circles, on both circles? They're called external tangents because they're on the exterior. So it's that word exterior, external tangents. Okay, if those are external, we change up the color. Oh, this is going to be rough. Well, what do you think that one's called? Internal, like your internal organs are inside your body. It's cutting inside the triangles, that's why it's called an internal tangent. How many of those are there, internal? Good luck, try to sketch them. Okay, internal tangents, external tangents, how many of you, I get that. Do those two make sense to you? Cutting through? Okay, perfect. Next part of vocab test. A, B, and C. Be careful. Use the page before. Try this on your own. Okay, be confident. CG. On your quizzes, on your tests, on your assignment, highlight them. CG, look at it. What is it?
It's a radius.
It's a radius. Thank you, darling. It's a radius. Alright, EG. I'm curious. Here's EG. Guys, shout out. What's EG?
Chord. Or a diameter and
Put them both and you'll look brilliant. It's a chord and a diameter. It's a chord because it goes edge to edge. It's a diameter because it goes edge to edge, but it goes through the center. How many of you put both? Alright, where's the AD? Oh, AD's right here. Great, shout out. What's AD? Tangent. Alright, my morning class said common tangent. What do you think about that? I agree with Callie. There's nothing to be common with. So just put tangent. It'd be a common tangent if there was another circle and they had it in common. That's where the common comes in. Okay, how many of you are 3 for 3 on this? Get it with vocab. You have one whole section of your assignment that's full of vocab like this. Match it up. You'll be fine. Okay, we do have some theorems to go over. Right here, they're talking about this radius compared to this tangent. Look at the angle they're forming. What do you think about it? It is. It's always going to be 90 degrees right here. So that's the first theorem. It's saying line L will be perpendicular to that tangent. If it's the radius and a tangent, it'll always be 90 degrees, which means we can keep using Pythagorean theorem. Okay, theorem 10.2 is just the same thing, only backwards. It's saying if you know this is 90 degrees, what do you know about the radius and the common tangent? You just know that it would have to be a tangent. If that's the radius, that would have to be a tangent if it's 90 degrees. Question. What does this mean? What is it saying about the Q though? Saying circle cube, Q is the center of the circle. Okay, the last one, theorem 10.3, it's saying if two segments from the same exterior point stop in this picture, which one is the exterior point? S, because it's on the outside. So they're saying if it shares S and S is tangent to the circle, these two pieces have to be congruent. So this is congruent to this. SR is congruent to ST. This piece right here will always be the same as that piece. They'll be congruent. That comes in handy later too. So you can just set stuff equal to each other. Okay, logically, how you feeling about those three? Do they make sense logically? Yeah? Okay. Let's do some examples. Flip that page. Okay, this one. This one we don't usually follow our notes step by step, but this one isn't too bad. It's actually very helpful. Right here you have the radius. Right here we have a tangent. If that's the tangent, tell me about this angle right here. Draw it in there. This is 90 degrees. Okay, shout out. Which ones are the legs in that picture? What and what? Ooh, good job. PQ and QR are the legs. So the hypotenuse, what's the hypotenuse? Be careful with that. Because right here, PQ is just R. QR is 8. What's PR? Ah, good work. PR, you've got to put it together, is R plus 4. So Pythagorean theorem, they set it up for us right here. So here's the hypotenuse squared. It's going to equal leg squared plus leg squared. Nod your head, be okay with that setup. Here's where, I don't know what you got taught last year. Did you learn how to do stuff like this? Some of you? Because what I see when I taught pre-algebra is a lot of students would do this. True or false? Big time false. It's not. Because what you have to do is FOIL. R plus 4 squared means you take R plus 4 and you times it by R plus 4. Did you learn that last year? Okay. Did you learn it as FOIL first, outsiders last? Okay, so when you do FOIL, you get this. Does that look familiar? There's not much in this chapter, I just gotta make sure. Maybe we'll have a day of practicing FOIL. Okay, so then we get that. R squared plus 8, R plus 16 equals just R legs squared. So it looks like they did two things at once. Right here, how would you get rid of R squared? Yeah, because watch what happens. You subtract it from this side, equal sign, cube balance. Subtract it from this side. So convenient, right? Gone, gone. Okay, what else did they subtract? Can you see it? Yep. Grab a calculator or do it in your head. What is 64 minus 16? What is it? 48? Okay. Are you staying with me on your notes? What do they do next? Divide by 8. What's 48 divided by 8? Done. Not too bad, right? Just be careful, because you have one almost exactly like this on your assignment, where the hypotenuse is a combination of two. So don't forget to add them together for the whole thing. Question 9. FOIL, this is how you do it. Are you ready? I don't know how your teacher last year taught you. This is how I taught my kids. So you do first times first, so that's r squared. Yeah? And then you do first times last, so that's 4r. R times 4 is 4. I'll write it down. So we've got r squared plus 4r. You okay with that? Let me change up the colors. Because everything gets times by everything, then you do this times this. So guys, what's 4 times r? 4r. That's another plus 4r. And then you do this times this. What's 4 times 4? There you go. So Ellie, what they did, they've got their r squared. Where did this 8r come from? Yeah, add the r's and then plus 16. Because otherwise they're not like terms. Whew. Yeah? Okay. Thank you for asking. Oh, this is the theorem. Guys, if this is an exterior point, it's tangent to the circle. What do we know about this piece and this piece? Write it in. So let's do 49 equals x squared plus 24. How do you get rid of the 24? You can do this in your head. What's 49 minus 24? Nice. That's so convenient. Why is that so convenient? Square root of 25 is just plain old 5. You survive that one? Okay, one more. Okay, try this one on your own. I'll write the setup, but try, test your algebra skills. So we'll have 4x plus 27. It's going to equal that whole thing. Okay, go. You added 18? Nice. So Nicole added 18 to both sides. Find your like terms. So we're left with 4x. Nicole, what is 27 plus 18? Okay, thanks. Plus 45. Bring down your leftovers. 5x squared plus 4x. Okay, Allie L, what did you do next? Or what would you do next? Oh, that's quite convenient. Did you notice what happened? It's gone. So nice. So we have 45 equals 5x squared. Okay, Garrison, what did you do here? Nice. Get rid of that 5 first. Guys, what's 45 divided by 5? So convenient. Why? It's a perfect square, right? What's the square root of 9? How many? I know Garrison got 3. Anybody else get 3?